This section is 8.2 Simple Interest. Before you watch this video, I would go ahead and go to the Blackboard site and print out the notes that I've posted there. What I'm writing on the screen will be posted online, so you can print those ahead of time and follow along the lecture a little bit easier. Let's first go through some definitions. Interest is the money earned when saving money. And you notice in parentheses I also have spent and borrowing. If you are, instead of saving money, if you're borrowing money, then instead of the money you get to keep, it's the money that it's going to cost you to do the borrowing. Interest works both ways. You either get the money if you're saving or spend the money if you're borrowing. The principal is the amount of money that you've saved or borrowed. Interest rates are usually given in terms of percent. However, in our calculations, in our equations, we're always going to be using them in decimal form. And finally, time is always given in years. So if you're given, say, something like 6 months, when you use this in a formula, you need to convert this to years. And to do that, you'd simply divide by 12 months, because in 1 year, there are 12 months. And that's really the only thing you need to watch out for when you're dealing with time. Alright, let's do an example. Another thing I'd like you to do is print out the formula sheet that's going to be given to you on your first exam. That's also available on Blackboard. What I'd like you to do is get used to using that. You're not going to be bringing your sheet into the test, but a sheet just like that will be given to you on the exam. And if you get used to using it while doing the homework, I think it makes the exams a little bit easier. One of the formulas on that sheet is this one. This is called a simple interest formula. The I stands for the interest, P is the principal, R is the rate, again in terms of a decimal, and T is the time in years. So let's see how we're going to use that. If you deposit $2,000 into a 1-year CD, a CD is called a certificate of deposit. It's something that usually just earns simple interest. And what I mean by simple interest is at the end of the time you get your principal back and you get your interest. So you're not earning interest on your interest like we will be talking about later with compound interest. So a certificate of deposit, or CD, is an example of simple interest. That CD is going to give you 2% of interest per year. And the question is, after 1 year, how much interest do you get? Well, we're going to use our formula. So my interest is simply going to be my principal times my rate, and again we're going to write that in terms of a decimal, after 1 year. And that's going to equal 40, or $40. What happens if I want to look at this after 2 years? Well, I'm going to use the same formula, but instead of 1 year for time, I'm going to use 2. And that shows that I'll get $80 after 2 years. Let's assume that instead of depositing the money, it's a borrowing situation. So let's say we borrow $1,000 for 60 days at a loan of 25%. Now it's a pretty high percentage, and hopefully nobody would be using a loan that was 25%. But generally you will find what you can get as a saver is much less than what you can get as a borrower. So the banks are making money on the difference between what they'll give you when you deposit money versus what they charge you if you borrow money. So let's use the same formula. Notice for the time I used 60 divided by 360. There's really 365 days in a year, but generally bankers use 360 for these types of formulas. And what I will do on an exam is say, assume 360 days in a year. When we do that, we'll get $41.67. Again, anytime we're dealing with money, I want you to automatically round to the nearest cent, even if I don't ask. The next thing we're going to talk about is future value, and that's usually indicated by the letter A. What the future value is the amount the account will be worth, or the total you must repay at the end of the time period. In general, you can think of the A as being our interest plus our original principal. That is, if I save that $2,000 after a year, I get not only that $40 interest back, but I get my original $2,000 investment. So if I went ahead and used the formula that I have already been given for interest, that is, I was equal to PRT, I can go ahead and factor out that P, and I get the next equation on your formula sheet, A equals P times 1 plus RT. Now on the exam you're going to be given these formulas, but I'm not going to tell you what A, P, R, and T stand for. So you need to know when to use the formula and what the different variables stand for. Let's go ahead and use this. What's the future value of a loan of $1,060 at 6.5% for 3 months? So what I want to find is my A. I'm going to go ahead and write out the formula. I know the P, that's how much I borrowed. My rate is 0.065. Remember, don't put 0.65, that would be 65%. And my time is going to be 3 divided by 12 because my time was given to me in months and I need to convert that to years. When I use my calculator to find this, I find that my future value is about $1,077.23. Go ahead and see if you get this same number on your calculator. You need to be very careful with order of operations and parentheses. What we'd have to do first is multiply this 0.065 times 3/12 and then add 1 to it, and then take that answer and multiply it by 1,060. Here's another kind of question. You borrow $2,500 and you promise to pay back $2,655 in 6 months. The question is, what rate for simple interest are you actually paying? We're going to use this same formula, A equals P times 1 plus RT. But now what we don't know is our rate. Alright, the first thing we're going to do is divide both sides by 2,500. Now I want to warn you, don't round early. Leave as many decimal places as you can in your calculator, because if you round too early, you'll get an incorrect answer by the time you're done. The next thing I'm going to do is subtract 1 from both sides. 6/12 is just equal to 0.5, so I'm going to divide both sides by 0.5. And I get that my rate is equal to 0.124 or 12.4%. Alright, here's another problem. You want to go on a trip in 2 years, and you know that trip is going to cost you $4,000. You can get a 4% simple interest CD. And the question is, how much should I save today in order to have $4,000 in 2 years? Well, you know this is a future value problem because you're looking at how much do I need to have in the future and how much do I need to save at present. I know that it's the formula A equals P times 1 plus RT because of the fact this question says simple interest. This is a simple interest formula, so I'm going to use this because this is a simple interest problem. Later on we'll talk about compound interest. Anytime you start using compound interest, you're going to use a different formula. Again, the most difficult part of this section is to know which formula to use and when. I need $4,000 in the future. I want to know how much I need to save today. I'll get 4% interest, and I've got 2 years. So I'm going to bring up my calculator. I'm going to take care of what's in the parentheses first. And so I have 4,000 equals 1.08 times P. So I'm going to take 4,000 and divide it by 1.08. And I'm going to make a little shortcut. I'm going to press second and answer, and that pulls up my previous answer, that 1.08 that's still stored in the calculator, and hit enter. And that tells me I need to save $3,703.70. If I do that, I will have $4,000 in 2 years if I'm earning 4% interest. One last bit in this section is about a discounted loan. Discount sounds good, but it's not a discount in terms of a cost to you. It's that the amount you get is discounted by the interest. That is, you're really prepaying the interest. That is, the lender collects interest right at the beginning, right up front. I'm going to borrow $10,000 at a 10% discounted loan for 10 months. The first thing I need to do is find the loan discount. That is, what interest will I owe on this amount? And so I fill in the formula like we have before. The principal is $10,000, the rate is 0.1, and the time is 8 divided by 12. And when I do that, I get that the interest is $666.67. So the next thing I do is determine the net amount I will receive. That is, that original $10,000 that I needed right off the bat, the bank is going to take $666.67. That means the amount of money I'm actually going to get is only $9,333.33. So then what we can do is calculate what the actual interest rate is of this loan. And we're going to use the I equals P RT again. And the interest rate was the $666.67. The principal is the amount that I actually received, the $9,333.33. The rate is what I'm trying to find, and the time is still the 8/12. When I do this, I find that my actual rate is actually equal to 0.107 or 10.7%. So discounted loans actually end up really costing you more money than you might think based on the plain interest rate that they give you.